Hi all the students, today we are going to study connected graph, disconnected graph and components of a graph. So let's start with connected graph. A graph is connected if we can reach any vertex from any other vertex by traveling along the edges. So basically, what does this mean? This means that there needs to be at least one path between all the vertices of a graph. That is, you start from one vertex and from that particular vertex you can reach to any other vertex of that graph. To be able to do that, you need to have a path between all the vertices of the graph. It is not necessary that this path is a direct graph. Two vertices may be connected by a path to each other via indirect paths. Those paths need not be direct paths. So the basic condition here is that the vertices need to be connected via a path. That path can be a direct path or that path can be an indirect path. In other words, if a graph G is said to be connected if there is at least one path between every pair of vertices in G, which is a graph. So if a graph denoted by G exists, then that graph is said to be connected if between all the pair of vertices of that graph there is at least one path. We'll see through an example. The figure below shows you a graph. Now this shows an example of a connected graph. Let's see how this graph is connected. You see, I start from vertex V1. Now if I want to reach vertex V4, I have two paths to do that. First of all, I can reach via vertex V2. V1, V2 and V4. Second, I can reach via vertex V3. V1, V3, V4. Then I can reach via V3 and V2 also. V1, V3, V2, V4. So basically there exists a path between V1 and V4. Though this path is not direct, but there is a path. Similarly, if I from V1, here we are taking V1 as the pivot vertex. So we'll see if there exists a path from V1 to all the vertices of this graph. From V1 to V4, there is a path. Then moving on from V1 to V3, let's check. There is a direct path from V1 to V3. We need to have at least one path. If one path is found, that is sufficient. We may have more than one path, but that is not the concern here. The concern is that we need to have at least one path. So this one path exists and we can clearly see the path between V1 and V3 is a direct path. Though it does not matter whether the path is a direct path or an indirect path. Okay. Then if we want to reach from V1 to V2, I can see that there exists a direct path between V1 and V2. So there is a path between V1 and V2 also. Then if I want to reach from V1 to V5, I can see that there is a path via vertex V2 and via edge A and F. So from V1 to V2 and from V2 to V5. That means there exists a path between V1 and V5 also. So basically, there are V1, V2, V3, V4, V5, 5 vertices, and from V1 there is a path to all other vertices of the graph. That means V1 is connected to all the vertices V2, V3, V4 and V5 of this graph. Now let's check for vertex V2. That means V2 becomes the pivot vertex now. So obviously there exists a path from V1 to V2, so vice versa, because this is not a directed graph. So that means there exists a path from V1, V2 to V1 also. This is checked. Then let's see if there is a path from V2 to V3. Yes, there is a path from V2 to V3. So there exists a path from V2 to V3 also. Then let's see if there is a path between V2 and V4. Yes, you can clearly see there is a path between V2 and V4 also. Then let's see if there is a path between V2 and V5. There is directly a path between V2 and V5. So yes, there is a path between V2 and V5 also. So that means there is a path from V2 to all other vertices of the graph also. So V2 Now let's check for vertex V3. That means V3 becomes the pivot vertex now. So if I check for V3, I clearly know that there is a path between V3 and V1. We have already seen here. Then there is also a path between V3 and V2. We have already seen here. You can see there is a path between V3 and V1. You can see there is a path between V3 and V2 also. Now let's see for V4. Yes, there is a path between V3 and V4 also. Then let's check for V5. There is a path between V3 and V5 via V2. From V3 first you go to vertex V2. From V2 you reach V5. So that means there is a path between V3 and V5 also. So we have checked for 3 vertices. V1 is checked. Then V2 is checked. Then V3 is checked. Now let's take V4 as the pivot vertex and see if there is a path from V2 to all other vertices of the graph. So, let's see if there is a path from V4 to all other vertices of the graph. So, for V4, there is a path from V4 to V1. You can clearly see V4, V3 and then V1. So, there is a path from V4 to V1. Then let's see if there is a path from V4 to V2. There is a path from V4 to V2. We can see via the edge E. So, there is a path from V4 to V2 also. Then let's see if there is a path from V4 to V3. Yes, there is a path from V4 to V3 via edge D. So, V4 to V3 you have a direct path. Then let's see if there is a path from V4 to V5. Yes, there is a path from V4 to V5 via the edge H. So V4 is also connected to all other vertices of the graph. Now only one vertex is left. V4 is also checked. Vertex V5 is left. So taking V5 as the pivot vertex, let's see if there is a path from vertex V5 to all other vertices of the graph. So from V5 to V1 there is a path. You can clearly see V5, V2 and V1. So via edges F and A you have a path from V5 to V1. Then let's see if there is a path from V5 to V2. Yes, there is a path from V5 to V2 via the edge F. Then let's see if there is a path from V5 to V4. Yes, there is a path from V5 to V4 via edge H. Then let's see if there is a path from V5 to V3. There is a path from V5 to V3 via vertex V2. So V5, V2 and V3. So path from V5 to V2 is via edges F and B like this. So that means you can see that there is a path from vertex V5 to all other vertices of the graph. So for all the vertices V1, V2, V3, V4 and V5, there exists a path to all other vertices of the graph. So I can say that this graph is a connected graph. Otherwise, if this condition is not satisfied, the graph G is said to be disconnected. Now let's see the example of disconnected graph. Just now we saw a connected graph. Now this is the graph that you are seeing is called the disconnected graph. Because in this graph, there is not a path from every vertex to reach every other vertex of the graph. Like for example, if I want to reach from V4 to V6, there is no path. If I want to reach from V4 to V7, there is no path. Or if I want to reach from vertex V5 to vertex V9, there is no path. So even if one such pair of vertex exists, then the graph is said to be disconnected. That means the condition is that there needs to be a path from all the vertices of the graph to all other vertices of the graph. Else the graph is disconnected. So here you can clearly see the example of a disconnected graph. Now this is a disconnected graph with two components. This is one component and this is one component, right? So you can see a disconnected graph with two components. So it is basically not possible to reach from the vertices of one component to the vertices of the other component. This divides the disconnected graph into different components. Here this disconnected graph consists of two components. This is one component and this is another component. So this is a disconnected graph with two components. So a disconnected graph consists of two or more connected graphs. The components in itself are connected, but separately they make up a graph which is but together they make up a graph which is disconnected. So these components in themselves are connected graphs. Like these two components make up a disconnected graph, but this component is a connected graph in itself, and this component is also a connected graph in itself. And each of the connected subgraphs is called a component. So if this is a disconnected graph, I can clearly say that this is a subgraph of that disconnected graph, and this is also a subgraph of this disconnected graph, and each of these connected subgraph, this is one connected subgraph and this is one connected subgraph. So each of the connected subgraph is called a component. So this is the one component and this is the second component. And you can clearly see that the graph in the figure above consists of two components, and hence this is a disconnected graph.